to all of my friends. Mm, Today I'm going to take the session on DevOps CI/CD process. Let me share the screen. Is it visible to you all?
Yes.
Yes, ma'am.
Yeah, that's great. Okay. Before starting the actual process of CI/CD pipeline, I'm going to explain a small intro about the DevOps, when actually the DevOps has been started and how it came into this beautiful world. Okay, DevOps is nothing but a collective body of knowledge. It's actually used in IT culture, automation, management, and organizational structure. Actually, this was started by a guy named called Patrick Deby. He actually got the idea, and he is from Belgium. In the year 2007, he started his ideas. He researched on DevOps, and later it formed a shape in the year 2009. But that was not executed properly, and those ideas has taken by the few more guys in United States of America and named it as DevOps Days. The prior name of DevOps was DevOps Days. Later it was named as DevOps in the year 2015. Many of the cloud providers like Amazon Web Services, Azure, many others have shaped up, and it was introduced to the actual world. DevOps includes both developing of software products, services, and the operations. So the key metrics for this DevOps is throughput and stability and the quality of the project. Are you clear?
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes.
Okay, thank you. So what is the use of what are the benefits of the DevOps? Is anyone is aware? Except these points, anyone can have an idea what is the usage of DevOps? Anyone? Okay, fine. No worries.
To build
I
a lot
will
of
explain.
automation pipelines around.
Okay. Why we are automating when we have a manual power?
To one is for repeatability, secondly for time efficiency.
Yes, exactly. If as Agile we have the iteration, we do need to deliver at least one functionality in every sprint. That's how we automate. So DevOps is most helpful in that for the cloud process. I mean, not only in the cloud, we can use on premises also. Going forward, I'll explain you everything. Okay. You can see here through DevOps we can we can deliver the project to the market fastly and higher return of investment, greater user customer satisfaction, increased efficiency, improved collaboration in the sense, both the developers, testers, and operation teams sit together, they will discuss, they'll collaborate, and finally with the help of everyone, they can deliver a successful product or some project. Then early detection and correction of issues. All this can be a continuous process in this pipeline. This earlier detection and correction of issues will be taken care of the continuous testing people. Okay, that's all about the benefits. Okay, now I'm going to explain what is the use of DevOps. See, prior to the DevOps, we do have the operations team, testing team, and also the development team. But no one is not, no one in the sense they are not able to properly communicate. That's why there are a lot of conflicts, there are a lot of misunderstandings. All these were happened prior to the DevOps. That is in time consistency. We used to lose lot of time, and dependencies are more, all these conflicts are resolved by the DevOps. We can see here DevOps is a collaboration between the development and operation teams, which enables continuous delivery of applications and services to an end user. The name itself, we have DevOps, but here we couldn't see the testing people. Dev, in the sense, the testing itself also included in the dev team. Ops is the people who deploy the applications and operate those applications. So this is a combination of 4 teams: testers, developers, deployment team, and operations teams. All together, it has taken as in DevOps. Okay, now once the future is developed and tested, it needs to be released to the end user. That is, we need an environment, right? So where the application is running and available for end users. Environment in the sense, we need some operating systems, either it is on-prem or cloud, whatever might be, we need some environment. So that's why we have an DevOps here. Through DevOps, we can provision. Provision is nothing but deploying the application onto the VMware or otherwise a cloud platform. To deploy that, we need one infrastructure. For example, infrastructure is nothing but storage, networking, RAM, CPU, all these things, whatever we will design an architecture for delivering or developing an application, the same thing is required even in the deployment side, that is for server side. So to maintain these environments on the local servers or on cloud servers. Local servers is nothing but VMware. Cloud servers are nothing but Amazon Web Services, Azure, so on so on. Did you got my point?
Yes, partner. Quick question.
Okay.
I'm not sure if you're going to dive into a little bit on operation team, but if I'm someone who's new into Scrum, I am also new into IT. I don't know any of this lingo, right? What is the easiest and simplest way you can be able to define what DevOps are, what they do, how do they integrate with operation team? What is operation team and what do they do? So 5 questions in one.
Yeah, sure, I will. See, operation, yeah, each and everything that will be coming in the next slide. Prior to that, I'm just giving the intro.
Awesome,
Okay,
awesome.
fine. Okay, next is slowly I will go and I'll explain each and every tool briefly without any confusion. Okay, can I
Yes.
proceed?
Yes, ma'am. Yes.
Yeah. Okay, fine. See how here I'm going to explain how DevOps is different from Agile methodology. We all are aware that what actually an Agile. Uh, See, it's just it addresses the gaps and conflicts between the customer and the developers. That is Agile, and even we are already involved in Agile world. But what actually the DevOps will do? Priorly, as I explained, DevOps is a culture that allows the development and operations teams to work together. This results in continuous development, testing, integration, deployment, and monitoring of the software throughout the life cycle. That was DevOps is collaboration. It's nothing but a collaboration between the development team and the operations team. That was the only difference. And now this is actually the DevOps. You people can see here, DevOps is one side is dev, the other side is ops, and in middle we have a release. So starting we'll code. Sorry, starting of this, we first of all will plan what actually the requirements are, how to design the architecture, what are all the resources, who are all the resources are required, how much time is required to deliver the build. Everything will be planned here. And next, the developer starts coding, and then it will be transferred into build by using few tools. Next slide, I'm going to explain each and everything. Next comes the testing. Once everything is done in the dev part, that will be released through the integration tools through the deployment team. Deployment team and operations team both are both are nothing but system administrators. System administrators will be involving in the operations team, whereas the deployment, the DevOps team will be involved. Both should be aware of everything. And here um, we have to note one thing: whether he is a developer or a tester or any operations team, everyone in the team has to aware of everything. At least a minimum knowledge is required. See, if operations team is having 100% of knowledge in ops, he must be aware of what actually the development team is doing, what are the tools they are using, and what the testing team is doing, and what are the testing tools are involved here. A minimum basic knowledge is required for each and everyone who is involving in this DevOps process. The same thing follows for the developers too. Even the developers has to know what are the tools the operations team is using. That's how they can easy to, for example, if an operations team is not available quickly, at least a few members have gone on leave, at least they are able to resolve the basic thing about the operations team, where exactly the error has arisen, so that to whom we have to contact. At least that knowledge is required for each and every member in the DevOps team. Did you got my point?
Yeah.
Okay, fine. Now I'm going to explain about a brief, not in depth, a brief explanation. What are the tools involved in this DevOps process? Then I'll go for the pipeline explanation. See, uh, as I said, the planning comes. Someone has to mute. Thank you. Yeah, see, planning, this session will be handled by us, project managers, product owners, scrum masters, everyone will be involved here, even the designers will involve. Then once the planning was done, it will be moved to the coding. Coding is the people, developers will develop the code. Here we use the tools Git, Jira, and Confluence. We are all aware about the Confluence and Jira. I'm going to explain about the Git. Git is nothing but a version control system. Here, what will be happen is a few things will be handled by the developers. Even the testers also will be involved. First, for example, some person has written some code on one functionality. He will push this code into the Git, and some other developer, for example, some X developer has written the remaining code. So he will push to the Git. So everything will be cloned. Clone in the sense A plus B equal to C. That C will be having both code of A and code of B. Again, if whenever the tester want to test the application, he will pull the code from the Git, and he will test. If there is any changes, he will commit that changes, and again it will be pushed back to the Git. This is the process will be handled in the Git, and we do have the repository to hold all the code, and we have two repositories, two types. That is, one is branch and the other is master. Branch is the different people will be writing the code, testing the code, and everything was done. That will be pushed to the master's repository. This is the thing handled by the Git. Under Git, we do have the two things. What is GitLab? GitLab is a command level, whereas the GitHub is a graphical user interface. So both can be used on their convenience. That's all about the Git. Any doubts, please?
I do have a question, Swapna.
Yeah.
So what would be the difference between the trunk-based development and a feature-based development?
Okay. Friend-based development and?
Yeah, and feature-based development.
Yeah, future-based development is like single-page applications. These are all handled for the microservices and micro front-ends, whereas the other one is a normal, it's a web application. developing the things at a time in the sense in the sprint wise model only, but not through the microservices. Microservices will be, yeah.
So feature-based development is only applicable to the web services?
It's not like that. We can go with even mobile applications too.
Okay, so then the trunk-based development is popular more with the microservice architecture? Is that what you're saying?
No, actually, all these I already discussed in the previous session. Just go through with that. If you have any doubts on that, you can come one-on-one. Because
Okay.
now I'm explaining about the CICD, it will become a bit confusion to others.
All right. No
You
problem.
don't mind.
Thanks.
Okay.
Uh,
Okay, guys. Yeah.
Just to comment, MK, the recording for that session is on our YouTube page.
Yeah.
Post the
Yes,
link
yes.
in the chat shortly so you can have access to it. Okay, MK?
Okay.
Okay.
Okay. Thank you so much.
Okay. Any other doubts on Git, please? If everyone is clear, I'll move for the next tool. Okay, fine. Next is build. See, coding. The coding will be in different type of programming languages. Either it might be a .NET, Java, Python, etc. But this code will be not understood by the machine. That's why it will be converted into the build. Build is nothing but jar files, var. Jar is nothing but Java archive files, all those such kind. It should be converted into an package. So if you want to convert that code into the package, we need to go for the build tool. It's nothing but Maven or SBT. SBT I am not aware, but Maven I am aware. But the same thing will be followed by the SBT too. See, Maven is nothing but it's a build tool provided by Apache. You are aware that Apache organization, company, right? That was the one which introduced this Maven. This Maven is used for, providing converting this code into the packages. And it also copies the resources like configuration files to build folder. The other thing is it also compile the source code. Source code is nothing but where the developers have written the code in the Git. And other thing is it copy the dependencies of the jar files to the build folder. All these things will be handled by the Maven. And next comes the testing. Once the build is ready, then it will move to testing. See, testing, again, we do have Selenium and JUnit. See, name itself says JUnit. Unit in the sense it is used for the unit testings to test the unit. Sorry, it's used for unit testing and repeated tasks like regression testing. These two tests are handled by the JUnit tool and Selenium. Selenium is nothing but it's used for functional testing. For functional, we use the Selenium, and for unit testing and regression testing, we use the JUnit. That's a part of the testing. Now, everything is ready from the developer side. That is coding completed, it moved to the build, and testing also completed. Now we need to release this build to the deployment team. This thing will be handled by the integration tools. Those are nothing but Jenkins. Are you aware about Jenkins? Did you heard anywhere? Friends?
Yes.
Yes.
Yeah. See, Jenkins is a very friendly tool, which is used to, it's easy for the developers for continuously integrating the changes or, deploying this code into the, for the deployment team. That is, yeah, it adds actually automation to the CI/CD pipeline. Without, not only Jenkins, we do have the GitLab. GitLab nowadays, it's also helping as an integration tools. Mostly someone or convenient to use the GitLab instead of Jenkins. These two tools are used as an integration tool. Integration is nothing but development. They are integrating the development part and the ops part. That's the Jenkins work. Now it goes to deployment. Deployment, we use Docker and Kubernetes. These two are the deployment tools. And we also use the cloud service providers like AWS, Azure and all, because if we want to deploy the application, we do require an on-premises, that is VMware, or some cloud, right? Cloud means AWS, Azure and all. Are you aware anything about the Docker?
Can you
Any idea on Docker?
can you explain? Okay, Humphrey's hand is up.
Yes, well, no, I wanted you to kind of, if you could narrow down, because AWS is kind of broad, and I know that there's others in the call that might be, may have heard a microservice or one of the services that AWS provides at this level. Perhaps you want to narrow down to that rather than maybe AWS in general.
Okay, fine. Docker is actually used for running, shipping, and deploying the applications into the container. Container where the container is nothing but where it is a place where we make our applications as an images. See, for example, if we want to deploy the application, we need some some vessel type in a sense, something to be holded. These applications need to be holded by something, right? That something is nothing but a containers. So to develop the containers, we required the Docker. So that was the usage of Docker. And also you might rise it out, if there isn't Docker, what is the usage of Kubernetes? Even the Kubernetes also deploy the same. It also hold the containers. Here the containers are nothing but pod. They are named as in pods. The only difference between Kubernetes and Docker is here auto scaling will not be available. Auto scaling in the sense, for example, if the server is down, the Docker, whatever it is holding, those applications will also go down. So that is the one of the drawback in Docker. But whereas Kubernetes is having the auto scaling part. Auto scaling in the sense, if it is down in one server, it automatically moves that applications to the another server, and it will be continuously working. And one more difference between Kubernetes and Docker is, in Docker, we use it to deploy only one application at a time. Whereas in Kubernetes, we can deploy multiple applications simultaneously without any doubt. That was the difference between Docker and Kubernetes. And here they have not mentioned about the Terraform. Terraform is also used. See, if we want to deploy an application in a server or an on-premises, we need one infrastructure, right? For that, we use the Terraform. Terraform is completely about the scripting, coding. We have to code to implement the infrastructure. Based on that infrastructure, we deploy the applications either into the Kubernetes or Docker. If it is a single page application, then we can go for the Dockers, because we only deploy a single page. But if you want to deploy multiple microservices at a time, then we go for the Kubernetes. Are you clear, guys?
Yes.
Okay, fine. Thank you. Now comes the operating system. Sorry, not operating system, operations. So here we use Chef and Sybil. And even they didn't mention the one more tool, Puppet. These three tools are used in the operations So operations, in the sense, we need to provision. Provision means we have to set up the various servers that we need in our infrastructure. So that will be handled by the operations team. Operations team means system administration. See, for example, prior to this cloud and all, we do have the system administrations, right? For example, if it is a Windows operating system or a Ubuntu, or it might be a Mac system, what system administrators will do, they will give a system, they will provide the networks, and they will give the storage to our systems. And if we are allocated some projects, for that, how much RAM is required, how much CPU is required, what are the hard disks, how much space is required for that project. All these things will be handled by the system administrators. The same thing even in the operations team. Operations team means they will take care of the either on premises, like normal servers, local servers, or a cloud servers. Cloud servers also same thing, but it is virtual, and we need to pay for the usage. That's the only difference between the cloud and the normal servers. So if the server is going down, then it's a duty of an operations team to make sure enough why the server was down, where exactly the issue was raised, and how to up the server. If any patches is required, any upgrades are required for that application, all these things will be taken care by the operations team only. Those team are nothing but system administrators, system architects. All these people come under the operations team. Are you clear now? Who are all involved and what are the duties in the operations team?
Yes.
Yes, ma'am.
Okay, thank you. Now it's a final stage, monitoring. See, everything was developed, deployed, and operations team also set ready. Now it is moved to the monitoring. See, monitoring is required. That is, we do have the Nagios, Splunk, and Datadog. Datadog is for the mostly used for the IoT and data analytics part, where Nagios and Splunk is mainly used. Nagios is nothing but a monitoring. Now everything is fine. For example, if there is an issues is rising, we require some logs. All these things will be handled by the monitoring team. They will monitor it's like a ticketing tool. For example, if there is an incident, we need to modify something. If it is a problem or it is a change, everything will be first, that all those things will be come to the monitoring bucket. They will assign the issues to a particular people. For example, if there is an issue in the development side, they will assign that ticket to the development team. If it is an issue with an operation team, they will assign that ticket to the operation team. The same, this was the rotation, a round robin method, that all the monitoring team will be handled. That's all about a brief explanation about the tools, what are all involved in the CICD. It's not only in CICD, it's a whole process of the DevOps. All these tools are used in the complete DevOps process. Are you clear? Can I move to the next slide?
Before you move, there are some questions in the chat. Do you mind if I read them out to you?
Okay.
All right. So somebody wanted to know what you meant by SRE.
Sorry, site reliability engineer. He is the one. See, if the DevOps team is not able to solve the issue, is more than an architect level. For example, it's like he's like an enterprise agile coach level. If anything is not resolved by the DevOps team, it will move to the site reliability engineer, who should be an expert in scripting, Python, Perl scripting, and all. He's the one who resolves all the issues.
Okay. At Olamide, is that okay? Clear?
Okay, fine.
And
Is
another
any
question
question?
before you move on.
Yeah.
Sorry, I'm monitoring the chat. So when you get to the questions and answers, I'll just read them out for you, okay?
Sure,
Can
sure.
you explain the difference between unit testing and functional testing?
Yeah, unit testing will be tested by the developers. First of all, they will write the code. Everything is fine. Now they need to test their code. Each and every functionality is working according to the requirements given. I mean, they will test the code. If everything is fine, then it is moved to the testing team. Functionality testing is testers will test whether each and every functionality is exactly like the test cases what they have written. They only test the functionality. For example, if I take one yeah, I mean banking project, for example, loans module. I need to, if I click the loan module, whether it is going to the options like personal loan, home loan, or some automobile loan. So whether this functionality is working or not, all this will be tested by the functional testers based on their usage. Someone can go for Selenium, someone can go for PyCharm. PyCharm is in Python to test the Python coding. That was the only difference. Did I clear your doubt, please?
That was great. Thank you.
Okay. Shall I move for the actual process?
Yeah, there's no more questions in the chat, so we can move on.
Okay. Thank you. Yeah, and what actually the continuous practices of the DevOps? We do have the continuous integration, continuous delivery, continuous testing. See, integration is nothing but here the development is also get involved, continuous deployment, and continuous monitoring and continuous notifications. See, notifications are nothing but if we need to, for example, we need to send it, some people will be having some tools for notifications also, but mostly few organizations use email and Slack to communicate, to send the notifications. Okay. Now I'm starting the continuous integration part. Actually, here the development, as I said before, just when I'm explaining this process, please be think with respect to of tools also. So CI is nothing but a continuous integration where the development team commits future implementation. Future is nothing but a requirement or bug fixes frequently. Bug fixes will be arised during the once the build is moved to the end user, and if any issues will be raised in the production, those will be come under the bug fixes. Even when the testing team raises any issues, those also will be come under the bug fixing part. Okay, now we need to integrate them in a shared repository. As I said, we have a Git, right? See, GitLab or GitHub. Every check-in can be verified using an automated build. That is, build is nothing but by using the Maven. And it is scheduled or configured with hooks to trigger a build, execute unit test, verify code quality, and create a package. Here for code quality, we use Sonar Cube. That was, I didn't mention because in that chart, we don't have the Sonar Cube. Okay. Now the practical flow of the continuous integration process. Here I'll explain very slowly. First, the developers commit the code to the central repository such as GitLab, GitHub, or Bitbucket when the future or bug fixing has been completed. As I said early, once development is completed, then it is moved to the build execution. That is based on the push or pull mechanism. Now, continuous code inspection will be done using the static code analysis, that is SonarQube, Android or JS Lint, etc. Did you understand what I just I read? Because I already explained the basics. That's why I read the lines here. Is there any doubt here?
No.
Okay.
It seems somebody's hand is up.
Sorry guys, I'm not seeing the chart because
Don't worry.
I'm only.
I'm monitoring the chat for you. So whose hand is up? Could you ask your question, please?
Yeah, guys.
Okay, Humphrey, oh, that's you. It's an old hand. Okay. Is that an old hand or a new hand, Humphrey?
No, that's a new hand. Well, I wanted her to go ahead and explain the sonar cube one because that's important. But also when we talk about in that previous previous paragraph, we talked about automated build. Like every check can be verified using an automated build. Can you expound on that? What's that mean?
Automated build. Yeah, that was done by the Maven. That will be taken care by the Maven tool.
I'm sorry, what tool?
Sorry?
Yeah, that's correct. Marvin
Maven.
is
It's
in
a
the
build
previous
tool.
slide.
Yes. Here you can see for build is taken care by the Maven tool. Are
Okay,
you clear?
gotcha. And then the automated build that's there, it does it have anything to do like the automated testing that some teams do as far as automating test scripts or?
Maven is nothing but we are, see, it is converting the code. Code will be in English language, right? That will not be understood by the machine. It will convert that into ones and zeros, binary form. That will be handled by the Maven. Did you got? Did I clear your doubt?
Almost, because when we say automated build, can you go back?
Okay. Here?
We say automated build that is scheduled and configured with hooks to trigger a build and execute unit tests and then verify code. That's that. So that's handled by one tool, Maven.
Yeah, first, see, continuous integration part involves Git tool, Maven, testing tools, Jenkins, and few more tools. That is for creating the package, we need an artifactory management. That tool were not mentioned in the diagram, but I will explain in this slide. And you have to I have to inform you one thing. I'm not a DevOps developer or DevOps. I didn't work in the DevOps team, but only I trained. I was an Agile project manager handling end to end. That is from the requirements till the project is deployed to the servers and it is moved to the end user. I'm handling everything. That's how I gain the knowledge and I'm explaining here. I never worked in DevOps.
Okay, that's fine.
So
Thank you. I
okay.
appreciate you.
Thank you. Okay, this is the process, and next comes, as I said, unit tests will be executed by the developers to verify the smallest unit of the code that we can done by using the JUnit. And package creation. See, the package creation might be in var or APAC files. Our packages are generated using the build tools like Apache Maven, Apache Ant. Ant is the other tool which work like in Maven also, but most of the organizations are familiar with the Maven. Next comes the artifact management. See, I didn't explain about the JFrog or Nexus. That is, I just said, right, it will, I have given some wrong info. Maven is only used to convert the code into build, that is jar files and war files, and that will be converted into binaries by using the artifactory management, that is JFrog or Nexus. These are the two tools which convert the jar files into the binaries in the repositories. And whenever the build get broken, we can send the notification through mail or Slack. See, if there is any error in the development while testing, we can send the notification, as I mentioned, through emails or Slack. Respective actions are taken to solve those build issues and fixed accordingly before going to the deployment. I mean, before integrating this code, if there is any issues raised by the testing team, that all will be sent to the developers, whether it might be a front end, back end, or any database developers, through the mail or a Slack. That was the continuous integration process. If there is any doubt, please let me know. I will explain. If everything is clear, I'll move to the continuous delivery process. Hope everything is clear. Continuous delivery is an extension of continuous integration. So in continuous integration, what we got an package. That is the output of the continuous integration. Now this package will be deployed to the, deployed. Continuous delivery means we are deploying this package into the non-production servers. Okay. So the process is through JFrog Artifactory, we will retrieve the version of the package that needs to be deployed in a specific environment. Here, environment can be either on-premises servers or cloud servers. I already explained what is on-prem and cloud. So different service models can be used for the deployment based on the requirements. Say few organizations deployed in Amazon and few in Azure, and few people will use the DigitalOcean, LimeNode. We do have many cloud service providers. It's all based upon the organizations. Next, infrastructure has a service. We do have AWS EC2 instances. Instances are nothing but servers, and Azure virtual machines is utilized. This is an example I'm giving. Platform has a service. We do have Azure app or web services. This is also an example. Are you clear now? Is there any confusion? Please let me know.
We're following.
Okay, thank you. See, I already explained you about the Docker and Kubernetes, right? That is containerization. That comes here. Containerization is an OS-based virtualization that creates multiple virtual units in the user space known as containers. And containers virtualize CPU, memory, storage, and network resources at the OS level. See, for example, as I mentioned earlier, whenever we take a system from an organization, they will set up everything and they will provide the LAPI to us, right? The same thing will be even that will be handled by the containers. Where it is a virtualized infrastructure, this will be given by the tool called Docker. And these stuff will be hope sandbox, in the sense it's a storage box where everything will be stored. And Docker is the most popular open source container format available. Docker images are stored in an Artifactory repository. Artifactory repository is nothing but a tool, JFrog or Nexus. Next, container orchestration. This was handled by the Kubernetes. It's the automation of different operational tasks required to run and manage the containers. See, in Dockers, we created the containers, but to run and manage, we need the Kubernetes, including container provisioning, deployment, scaling in the sense Maintaining the servers, management, load balancing. Load balancing means if there is a much flow of servers, for example, when we do have some offers, for example, Thanksgiving Day is coming on, right? So there is a lot of discounts on the websites on the products. So most of the people will be making use of that website. That time we need a load balancer. Otherwise, the server will go down, and that website will not be available for the users. Hence, we require the load balancing and networking. Networking is an important one, because if you want to connect to the any of the website or anything, we do require the network. Network in the sense it might be an internet, or if you want to connect locally, we need some protocols and all, right? That's why we use the networking. Tools used are Kubernetes, as I said, and OpenShift. OpenShift is one of the open source tool, which is also used to manage the containers. Next comes the configuration management. Configuration management, I said, right? It's a Chef, Puppet, Ansible. Those are the tools involved in the configuration management. That is where the team is, the team involved here is operations team, which is used to manage the environments effectively through the tools like Chef, Puppet, or Ansible. Here, environments can be, as I said, on-prem or cloud servers with different operating systems. Now, the automated deployment to any non-prod environment can be implemented using the batch scripts, shell scripts, or PowerShell script. See, now everything was, was clearly structured. This automated deployment should be implemented through scripting only. So a DevOps engineer has to have at least minimum 2 scripting languages. Either it may be a PowerShell, or it may be a Linux, or it might be a batch script. Any 2 scripting knowledge is mandatory for a DevOps engineer to, to be involved in this process. Next, most of the automation tools provide facilities to deploy the application packages in the form of plugins. Plugins are nothing but, see, each and every tool, see, everything we are co-located, everything is integrated. Plugin is, for example, even Jira is a plugin for one server. Every tool is a plugin here. Tools used for automated deployment were Azure DevOps, Jenkins, Atlassian Bamboo, etc. Finally, the objective of continuous delivery is to make product increment ready to deploy with a faster time to market and with high quality. See, one more thing here, continuous delivery and continuous deployment, both are same. The only difference is continuous delivery, we are going to deploy the application in non-production. Non-production means those servers will be local to our organization. Whereas deployment, continuous deployment is the applications we are going to deploy in the end user side, that is production servers. That is only the difference between the continuous delivery and continuous deployment. Next comes continuous testing. Without testing, we cannot we cannot guarantee that whatever testing, where the tester team is involved and continuously testing about the coding functionalities and all. See, once a package or application is and they are also involved in the once everything is done, once everything is deployed, even though the testing is required. For example, if a server is going down, otherwise the application is not properly available, all these things will be tested by the testers. What they will do, the operations team people will create one non-prod testing server. So, and there the testers will test the application, and they will, if there is any bugs, they will raise it and they will move to the either it might be with the developers team, or it may be with the deployment team. For example, we might get the issues in Docker also. Sometimes the services will not be running properly, and then the Docker team in the sense deployment team, that is the DevOps engineers will get involved, and they will check why the services are not running properly. And if it is a fault with the developers team will test the microservices or micro front ends, everything. It's depend upon the issue raised by the testers. Even testers are also plays a major role in the DevOps, in this process, because without them, we doesn't know which part is working properly or not. That's all about the stuff here. You can see once, in continuous testing, we do use two types of things, that is behavior driven and test driven development methodologies. Are you guys with me? Am I going fast?
We're here.
Okay, fine. Then the practical process of the continuous testing. We have to create the test environment in the cloud platforms. Containers can be utilized for creating the test environment. Here we can use the Selenium hub can be created using containers, and functional test execution can start once all the packages created using CI and deployed in a QA environment using continuous delivery. JMeter is used for load testing. See, there in that tool part, they didn't mention the JMeter. Even the JMeter is used for the performance and load testing. That's all about the continuous testing. Any doubts, please? Hope everything is fine. Any doubts, please rise.
Hi, this is Kulvinder. I have a quick question. I know you mentioned that all these tools need to be deployed to cloud. Does it have to be cloud-based system for continuous deployment process?
No, not at all. I already mentioned both on-premises and cloud. Either it may be on-premises. On-premises means a virtualization, VMware, ESXi, or it might be in cloud. It all depends upon the client requirements.
I see.
There is no mandatory it should be a cloud. It can be anything. But the process is the process will be the same, either for on-premises or for cloud servers. Okay, next, I already explained about the continuous deployment process. The only difference here is the same tools will be used, the process will be the same like continuous delivery, but the only thing is this will be happen in the production servers. Those are at the end user servers. That's the only difference. And while doing the continuous deployment, security, governance, security compliance is mandatory. That's the only difference here. See, here I mentioned continuous delivery and continuous deployment might use the same tool set, same way of deploy package in respect to environments. The only difference is better governance is required for continuous deployment. So last but not least, continuous monitoring and notification process. See, it's important to monitor the application as well as the infrastructure, irrespective of production. Production means continuous deployment. Non-production means continuous delivery. Mostly we can monitor the CPU and memory utilizations. See, again, in monitoring, we do have the different type. If it is an application monitoring, then we use Kibana. Kibana is a one tool, and ELK is the Elastic Search. These two tools are mainly used for the application, monitoring. If it is on server side, Then we go for Grafana and Prometheus. These are the tools used. And for notification, we mostly use Mail or Slack. So that's all about the continuous integration and continuous delivery pipeline. Are you clear with my session?
Hi, Swapna. Sorry, quick question again. What did you say Kibana is used for?
Application monitoring. If there is any issues in the applications which are deployed in the servers, then the monitoring tool used is Kibana, Kibana.
What's the difference between Nagios and Kibana? I know you mentioned that's used for monitoring as well.
Prometheus or those are used for the server side monitoring. If server is up, down, any CPU issues, memory issues, storage issues, then Grafana and Prometheus are used. I mean, it will be visible. Grafana will be visible through dashboards. Did I clear your doubt?
So hardware, servers, etc. Is Grafana and Nagios?
Nagios is for a
Application?
ticketing tool. Nagios is for a ticketing tool. Like it's like ITIL process, that is incident management tool. See, if you get any tickets, that will be raised. If any issues, then it is a problem incident like that. It's a ticketing tool.
Oh, it's an
Like
alerting
Jira.
tool. Nagios. Okay.
Nagios, yeah, it's a ticketing tool.
My understanding was that it's an alerting tool.
Yeah, it's a ticketing, alerting, yeah, different names.
Okay, thank you.
Okay, fine. So what are the benefits of the DevOps CICD process? We can reduce the risk. We can deliver fast, and we can generate extensive logs by the loggings. I mean, as I said, Grafana, Prometheus are used for the logs. And you can make easier rollbacks. Rollbacks means one of the biggest advantage of a CI/CD pipeline is you can roll back the changes quickly. If any new code changes break the production application, you can immediately return the application to its previous state. Usually the last successful build gets immediately deployed to prevent the production outages. Production outages in the sense mostly the server might be down. Otherwise, for example, if there is any data has been overloaded, all those things will become in these outages. Mostly outages in the sense server power off, all those things will be there. That's all about my session. Thank you all. Let me know the feedback.